This is a recording of the OREF meeting held at the 6th of August 2024 in Kirkwall. The presentation was given by F Macleod and Elsa Ramirez, both of Leask Marine. Unfortunately, during the early parts of the presentation, the sound failed, and so this is being revoiced. The proper voices come in at around 7 minutes, but in the meantime, this following is a further introduction. The company was formed back in 1985 and by Dougie and Karen Leask, mainly working in Orkney waters, but now has grown significantly to have over 60 personnel, and this rises to over 100 personnel at various times of the year. The experience that Leask Marine has had has been very extensive in all phases of project life and has a large portfolio of customers. With now over 39 years of experience, Leask Marine is in a prime position to make the most of the opportunities around Orkney and has an excellent safety record, which is highly valued by clients who come to use their experience. Over this period of time, they've undertaken a huge number of different operations, and some of them are shown here on this slide. Of most significance is the fact that they've operated for nearly 500,000 vessel operating hours and performed over 45,000 dives. The total amount of number of projects engaged in is nearly 1,000, and over time this will continue to grow. They have experience in wave and tidal, offshore wind, marine construction, renewable infrastructure, and so many other things that go on in the seas around Orkney and indeed increasingly around the world. The fleet comprises a number of vessels. These have been built up over a period of time, and Leask Marine have extended from initially working around fish farms and small construction to now working across the world with a number of different vessels. The larger vessels are shown in the top line and are effectively centred around a vessel type called a multicat, which is effectively a flat bottom vessel which has got cranes and rollers and large winches which allow it to handle heavy weights and bring them onto the deck. Of most significance at the moment is the fact that they are working in wave and tidal, and this is really being driven by the fact that Orkney has remarkable local resources. The ORF members will probably be familiar of the scale of resources which exist, and this graphic on the right hand side shows wave energy that impacts the islands. The large part of the growth really came out of working with EMEC, the European Marine Energy Centre, which was set up in 2003 to test wave and tidal energy devices. It's centred in Orkney, and as a result of the number of developers who have come along to the centre, this has meant that this gives Leask Marine and others significant customer base to then sell their services to. The number of projects that have been engaged in is also extremely broad. They've worked with over 26 different tidal developers, 9 project developers, and worked in 21 countries and operated in 13 of those. There have been over 200 projects in total in this space, and these are extending now into offshore wind and other similar technologies which are out into the sea. It's seen as a major growth area for the company because the scale of particularly offshore wind that's about to happen around the country and particularly around the north of Scotland is considerable, and this presents a huge opportunity for marine contractors to make the most of the developments that are coming along and find ways to sell service to them. Leask Marine have been very successful in doing this based on the experience they've had and being able to show that they know what they're doing in the harsh waters around the north of Scotland. One of the most impressive technologies that exist at the moment is that by Orbital Marine Power. This is a tidal turbine, and the view on the left hand side is the aerial view or the plan view showing the machine on site. Bottom right hand corner shows the point of launching of the turbine when it was towed off the floating barge or the submersible barge by Leask Marine's vessels. The turbine was then towed up to Orkney and has been installed in Orkney waters and operated over an extended period, and is the world's most powerful tidal turbine, rated at just over 2 megawatts. It's able to supply around 2,000 properties and is continuing to operate up in the Fall of Warness on the EMEC test site. Some of the most important features of the turbine is the fact that it was designed to work with these small-scale vessels that Leask Marine have got, such as the Multicat, which you can see adjacent to the turbine. The whole project was designed both with the intention of using the tidal resources, but also the supply chain to make sure that the resources are accessed in the most efficient manner. In addition to working with Orbital, Leask have been most recently working with Motion Energy, and they have had installations out on the EMEC test site in the fall of in Scapa Flow, but also more recently out east of Orkney, which is what this photograph shows. This was an occasion when the machine was out in the harsh waters off the test site, and there is good video on the Motion Energy website showing the scale of waves that happened. But here, Leask Marine were able to provide the project management, the vessel charter, and also the whole issue of fastening equipment to the vessels, and making sure the whole system went off safely. The offshore trials were completed, and now the site has been decommissioned with the moorings removed back to shore and the site returned to its original state. Overall, the whole package was strongly supported by Leask Marine. In addition to those, there are other machines which are going to be coming along in the near future, and these principally comprise machines by a company called Nova Innovations, who have been doing work in Shetland. This work in Shetland was also supported strongly by Leask Marine, and they are now bringing their expertise down to bring their machines down to Orkney, and will be supported once again by Leask. This is a photograph of one of the machines sitting on the quayside up in Shetland, and the intention is to bring some 16 of these turbines and install them on the seabed in the waters off the Fall of Warness, or in the Fall of Warness, to be generating from 2026 to 2027.
Together will not have the power generation that we will have here in one place in Orkney. So we're very proud that 16 turbines are going to be put in. They're going to be manufactured in Edinburgh. So again, Scottish knowledge. So what we're trying to get over here is, we've heard about these products all being developed. They're now coming to commercialization. That's the really important part. Technologies have been developed, they're robust, and they're becoming very much commercial. Okay.
Another big developer that has been here for a while now is Magallanes Renovables. So as John have said, Scotland has the knowledge, which actually brings people from outside to try to prove their devices, to try to prove their concepts, and they want to use, obviously, the knowledge that we have accumulated through the years. These developers is a great example of them. They've been here since 2019. They've been on and off the site. Sometimes, you know, there is prototypes, so there are things to change and modify every time. We have created a really good relationship with them to the point that actually we've been working hand in hand to develop their next generation device, which you can see on the top screen, which is slightly different from the one we have currently. So it's a floating tidal turbine. And they also have planned to extend it both in EMEC and in Wales as well. So being actually helping them to characterize the resource on the Wales site called Morlays. We've also been working to develop new mooring foundations for them and working in the new mooring system, as well as the cable management for them, which is all lessons learned we have gathered here after the testing in Orkney. Other developer that we've been working on is Minesto. They're from Sweden. Once again, they wanted to approach us for knowledge of being working in flood awareness. They're currently in the Faroe Isles. So we actually have work on the Faroes. We mobilize the full boats, and in this case, this is a gravity base that actually was fabricated in Orkney. So that was fabricated by yourself here in Hadston. I don't know if you know about Minnesota. So it's a slightly different concept of tidal energy. It's kind of a kite, so it looks like a plane, and it's in the middle of the water column. So it's a really interesting and really different approach to get a tidal developer. So it comes with a different kind of challenges that we haven't really exactly seen here in flood awareness, but it's all part of the lessons learned and still quite applicable. So one of the challenging things when working with tidal is you actually need to target certain times of the year. So you cannot really do the operations all the year round because the tides are too strong. So, we have to work in probably maybe 1 hour, 2 hours times a day, or per 6 hours, which is when the tide drops. So, it makes it challenging, but it's a lot of things we have learned through the years, thanks to all the developers that have come across EMEC sites.
So just a quick brief, because of our expertise, we're now working further afield as well. This is a device that we've just taken out of in France. And I think just so that you can actually see the scope of the size of some of these machines. It was one of the 3 largest vessels on the planet that can manage to crane and handle these devices from subsea that we chartered in to manage this device. And again, it was 1,500 tons of hardware taken back ashore. We're also been working with developers, as I said, around the globe. This is us doing studies in Guyana, so South America, for supporting the local Amerindian native tribes, so that the cost of getting fuel airplaned out to these remote communities is hugely expensive. So if we can use the local resources, i.e. the river, generate power, then obviously it reduces greatly the need for the high cost of fuel being taken out to operate generators. The difference for this will be that instead of operating off generators for maybe 2 or 3 hours a day, if you think of schooling, cooking, living, having television, and just having access for that many hours a day, by having this technology, what we'll be able to do is be able to produce enough power with batteries for 24-hour operation. So becoming a completely normal way of life, which again keeps the communities together and also encourages the younger members of the community to stay within the community as well. They don't feel the same need to have to go away. So hugely important, and again influence from the technology here working around the globe. Quick piece on offshore wind. The technologies that we've used in wave and tidal help in the offshore wind sector as well, especially with cable management, cable stabilization, etc., etc. So we use a lot of our expertise and in working high tidal flow areas for things like scour protection, etc., in the offshore farms. So we've worked on 52 major projects. In that time, there are, if I remember rightly, about 28 offshore wind farms currently around the UK. We've worked on 18 of them and worked on another 10 across Europe. So we're pretty much known to most of the wind farm operators. A lot of the work we do, we don't advertise hugely because a lot of it is O&M ops, but it's just to know that it's Orkney businesses are working around the UK and around Europe on these wind farms as well. So the kind of stuff that we're doing, this is cable protection systems. So Elsa will explain in the top corner exactly what we're doing there.
So basically this wind farm has kind of completed that first kind of decade of its life. And of course, they start seeing things getting wear and tear or getting tired or challenges they never really anticipated at the construction of it. Now they're coming with some issues or troubles, or they're trying to mitigate those issues and troubles happening. So this is, for example, a case of the wind farm is in a high tidal range, which means they never really expected the tide to change or affect as much as it's doing right now. So basically the cable is having a higher vibration than what they expect, therefore it's getting tired. Basically the vibration is like rubbing against the platform itself, which it could create a major issue, because if one cable goes, basically they shut down or the full line or the full farm, which will be major losses for the industry. So they approached us to see if we could help them, and we say yes. A lot of the things that's happening right now, it's things that I had never come across before. So in that thing, we are really proud. So we always think outside the box. We try to have a different approach. And as John said, being working on tidal was not new for us, but it was new for offshore wind. So for that we created, well, we didn't create it, but we work in conjunction with a wind farm and another company to create basically bend stiffeners. Just helps to stabilize the cable. But for this we actually needed to use a lot of divers, which once again is one of the strengths for us, working in tidal conditions with diving. It's not an easy task. So we've been working in around 100 turbines over the last couple of years, basically installing bend stiffeners all around. As you can see, we actually needed to create deployment tools that didn't exist. So they're all is invention of in-house invention. Basically, they were also fabricated in Orkney. As you can see it there, they're not the most magnificent technology, but however, it doesn't exist. And if it doesn't exist, you cannot really help it. So that's a large system, or we call it a large system. It's a launch and recovery system for the bend stiffer. As you can see it here. We have do a lot of lessons learned. As I say, we have worked in along different years now. So we are learning from our own, no mistakes, but to make it easier for us. Yep. So at the beginning, we just basically used to crane it inside to approach it to the turbine. For the next campaign, we realized it's not the best way, because there's a lot of influences, the wave, the wind, the bouncing, and all of that. So we create this tool, which make it way easier, also safer for the diver. And basically we've just been working on that. We also, something that we're trying to encourage offshore wind, is to take practices from the wave and tidal. For example, we work a lot with moorings. 4-point moorings is mostly a must for us on the tidal sites. Offshore wind never have used them. So it's always a bit of a challenge to try to convince them that nothing is going to go wrong. Or something we've been doing basically for 10 years. So it's always a bit of breaking that, or crossing that bridge to be okay, guys, this is, we've been working in 5 knots of tide, you have 2, it's going to be all right. So it's a bit of a challenge every now and then, but that's what makes the projects more interesting. And obviously that helps us to get more reputation of, we know what we're doing.
So, again, just using different technologies, this is another one of our drill rigs. We are actually now developing anchor and seaweed, mussel and seaweed installation between the offshore wind farm pylons, so that what we're doing is utilising the footprint and the space for multiple technologies. So you've got an offshore wind farm that's creating wind, but between that we can run mussel and seaweed lines so that we can grow seaweed, grow mussels, and therefore we're using the space better and greener as well. So technologies that we're developing with these companies, we're doing this in Belgium just now. We're putting in 200 as we speak. They're offshore doing that today. So just to give you an example of being developed, working from Orkney, we're using technologies from other resources. What we want to convince these offshore wind farms as well to use the possibility of wave as well, so that there's multiple green technologies being used in the one space. We're working at the moment on, you might start seeing this on the television coming up over the next 2-3 years. We're working on the Princess Elizabeth Island. So this is going to be a man-made island in the middle of the North Sea in Belgium. And we're creating a natural harbour for vessels that are out working on all the offshore wind farms in the North Sea to come in and to recharge their batteries and from this safe harbour that's been artificially built in Belgium. So it's the world's first. We're very pleased to be part of the project. It's a huge infrastructure project with multiple international companies, but they've come to us for some specific work that we can help them with. So again, we're very proud of the fact of these are really groundbreaking technologies being driven by ourselves here in Orkney. Quick one, when we say we're working everywhere, we are working everywhere. In the USA, the USA doesn't understand multi-cat style vessels, and they're just getting into the thoughts of offshore renewables. But because of that, they don't have the experience or the technology, so they're using basically European companies, Dutch and Italian. And because they've worked with us over many, many years, we're out there helping. We've been doing that for a number of years and we'll continue to do so this year and next year. We've been up in Canada doing work as well. So what we're trying to say is, for local business here in Orkney, we're quite proud of the fact that we get called in business to business all over the globe. A lot of the stuff, what we call the nearshore works. So for the electricity to come from these turbines, they need to come ashore. So what we do is a lot of the shore works, the capping, the punch out is when the drillers punch out through the seabed, and therefore we then need to put in the ducts. So if anybody's in Scapa Flow at the moment and sees long lines of pipe sitting in Scapa Flow and wonder what it is, they're actually 1.4 kilometres long, and there's 4 of them there, and we're putting them in at Hornsey 3 offshore wind farm at the moment. So in the southeast coast of England, we're going to be towing them down. The first one will get towed this weekend, and we'll be inserting them up from the sea up into the shore. So again, we're at the forefront of the technology development in these offshore wind farms, and it's involving Orkney and Orkney companies. That's a spelling mistake by me. For anybody that knows Nairn, it's Ardersier, not Ardersier. So what we're doing in Ardersier at the moment is, Ardersier was an oil and gas manufacturing platform base near Inverness. It's been shut and mothballed for many, many years. From somebody that's I'm from Nairn, so all the family worked there for many, many years. And it's been mothballed. However, the port is being started up again for offshore floating wind. So they've got the first contracts there. So it's silted up so badly over so many years that we are down there just now. We're doing what's called PUXO, so possible UXO, unexploded ordnance. So we go down there and we clear the potential UXOs, and also clear it so that the big dredging vessels can come in and dredge. So we'll be doing those works for some time. But again, all this technology developed by ourselves. So we'll find the spot that we think there's a possible UXO. We'll clear it. We'll put it through graters. We've got magnetic.
Metal detectors and
metal
magnetic
detectors
bands.
and magnets in here to make sure that we collect everything that's coming out of the sea and there's no debris going back overboard. What we're helping here is using more energy transition from other uses, ports that have been mothballed, to get them up alive again for the renewable sector.
And well, I kind of touched a little bit on this, but being a new industry, there's always a gap, and you don't really know there's a gap until you stumble upon it. So that's something that's happening to us quite constant, I would say. But it's always, as I said, we face it like basically as a new challenge. It's quite interesting as an engineer, at least, probably not for everyone, but it's always quite cool to find something and you realize oh, I don't know how to do that, and there is nothing outside to do it. So through the years, we have developed our own tooling. We do the usual thing. We try to go off to the market, suppliers, and be like, oh, do you have something for this? And we start getting a lot of no answers. Instead of like being like, oh, okay, no, we have to like think completely something different. We're like, well, what we really need is something to do this. So we have take up the challenge of ourselves. So we started developing our own technology. Could be really simple as hydraulic grabs. Hydraulic grabs is basically, you have seen Toy Story and the claw. No more explanation than that. But, given the special infrastructure on the seabed, sometimes a standard grab doesn't work, doesn't do the job. So we have developed a couple of grabs over the years.
So they're ultra sensitive, so that they're not going to break the cable, the infrastructure assets. When you're dealing with cables that are hugely expensive, you don't want to be breaking them, assuredly. So it's for stuff like that we're developing.
Same. We are constantly recovering chains, so we develop more grabs. We have created more in light unit storage, that's what we call it. So basically, something we leave on the seabed ready for us to collect, and we don't have to it's basically saving time and saving more work for us. So basically, we leave it on the seabed and ready to collect. We have developed what we call a recovery post. Very simple on the name. Basically, you have a cone that locates on top of it with a hydraulic shackle. Hydraulic shackle is basically a pin that goes hydraulically, and it closes when you have your target on view. It usually works with a drop camera. So that's something else we have developed through the years of doing operations. You want to move to the next one, Joel?
It doesn't want to. Oh.
And probably the biggest one, or the most challenging, interesting one, it's what we call the Raptor SDR. SDR stands for Submersible Drilling Rig. Once again, developers start approaching us trying to install rock anchors. We went onto the market probably 6-7 years ago. There was nothing out there. Or the things that were out there were completely out of the budget from a lot of developers. We have to remember that developers usually work in a really tight budget, so they don't have the luxury of go and hire a massive drilling rig or a really cheap. So when we realized there was nothing out there, we decided to start making one ourselves. So it's been on the making for 5-6 years now. It started completely in-house, honestly, just hand sketches, board sketches, everything that we could just throw at the board and see like, okay, what do we need? And at the end we came with the Raptor, which you may have seen it. I don't know, we have it a couple of times upright in Hadstone. It's not hard to miss. It's big and orange. It's quite a unique thing. Some people sometimes think there's a rocket. It's not a rocket, it's a drill rig, guys.
So Elsa undersells herself. She developed this technology, she designed it, and we built it here in Orkney. It's been a £3 million investment, which is a lot for a small business like ours, but we're really proud of it. So these legs slide up, as you can see, so it can pack into a 40-foot open foot container, so it can go anywhere in the world. It's been developed so it can work over small multi-cat style vessels, so that you don't need a big drilling ship. So what we can do now is we can put in an anchor at 1/10 of the price of getting a drill rig ship in. So properly developed technology, and to support that we've actually got a range of anchors and anchor type solutions that we've developed now as well to support that. This is what's called a grouted anchor pile.
Yeah.
And basically the cutting teeth are at that end, and basically it just grinds its way down until you've got to the depth that you want, and then it releases.
We did the first project, as I said, it's been in a developer for a long time now. So the first project was actually done on December last year, which probably, we could have chose better conditions of the year to do it, but I say we always like a challenge, and why not December and the Faroes? So, as I say, we've been working with a developer, Carminesto. So they are the ones who actually, new technology always will create some fear. And we are trying to actually engage with developers to trust us, to prove that this is the way forward. The industry needs to reach commercialization and simply cannot do it the way that we're doing it right now with a lot of gravity bases and a lot of chain. The footprints are getting fighted over constantly, as John said. We're trying to, optimize spaces on wind farms already. So, there is a very synergy of different industries in one place. So for us, this is the way forward. We need to do a smaller footprint for these devices. So Minesto was the one who trusted us to carry on the installation of our first anchor. We have installed it in the Faroes. There's a massive tide as well there, about 7 knots, which is basically almost as maximum as we can go. We were working on a site that's 80 meters water depth. Once again, the drill rig can go up to 100 meters. At the moment, it's designed for that. And that's just simply because of the limitations to pump hydraulics into it. It probably can go deeper, but we limited it to 100 meters as it is at the moment. As John mentioned it, we have to do it quite compact, which limits the size of the anchor we have. But when we did our trials to see the capacity of the anchors, the anchors exceed the capacity beyond imagination. So for example, we were going to test a small anchor, which we were hoping to fail at 250 tons. And we didn't. Yeah. We actually pulled it all the way to 420, and the anchor didn't fail, the rock did. So, there was a lot of things that really we're quite happy with it. So we have all that paperwork to backing us up to do the first project. So it's a 6-meter anchor, 800 million diameter, a bit more actually, and 80 meters water depth. And that was the first installation. We did it I think we did the full installation in 2 days.
Yep.
Which, way faster than doing backwards and forwards, because usually these installations for these kind of devices require something between 300 tons. And I don't know if you know the scale of what 300 tons look like in chain or concrete, but it's not a one day you go and you drop it. No, it's a constant back and forwards. Pour, pick up something else, drop, pick up something else and drop. So maybe something that will take us a week. We did it in 2 days. So, it's an improvement all around.
So this anchor itself is 12 tons in weight, and holding capacities in excess of 2,500 tons, somewhere about that. So again, the holding capacity of these things is quite incredible. And that's what we need to do if we go to arrays of devices. That's the purpose of us moving these technologies forward. But they have to be a cost-effective way to move forward for developers.
And this is just
so you just see the cutting heads there. They're sacrificial, so that will stay in with the grouted pile.
Yeah, basically the anchors just get tailored to whatever it is the need of the developer of the rock itself, because you don't know really which cutting head you're going to need until you do a little bit of a site investigation, which is another thing we didn't realize. There was a lot of things lacking in the industry. When we started engaging in anchoring solutions, we realized that we need to know what kind of rock you're drilling off. It's pretty basic if you think about it. Actually, you need to know which rock you're going into. But apparently no one has done enough ground investigation all around sites anywhere, which was a big shock for us. It's a major surprise, if I'm honest. So, when we approach our client, we always say we need to know which is your site characteristics, what is the rock you're going into. And the clients were like, well, we don't know. And we're like, okay, why not? So, once again, we went out suppliers to see who can do ground investigations. Once again, the only thing to do is massive boats. So our approach was, we already have a drill rig. Why we don't try to see if we can actually extract cores and do ground investigation ourselves? So that's what we did. Our most recent bigger campaign, which is pretty fresh, we did it last month. It was actually here in Fall of Warnes. We did 4 core samples in Fall of Warnes. This is for Orbital. So Orbital is, getting to the next stage, and they want to know what is the possibility of installing rock anchors, which actually they're already committed to it as well. So we're doing all the phase. So we extracted 4 core samples. The uniqueness of these ones, they are longer than standard. So normal core samples go between 1 meter and 3 meters, and then you usually need a carousel. So basically you drill 1 meter, you spin it, you do another meter, you spin it, you go another meter until you reach between 3 and 6 meters, which is the minimum to like get a good flavor of what is the rock it. So ours can do 4.5 meters, which is once again one of the unique characteristics. No one else can do that length. Once again, we're pretty proud of we're breaking that barrier once again. And we're getting a lot of interest in for not only tidal, but also for offshore wind. So Scott Wind has approached us, Thistle Wind Partner has approached us, Orkney West has approached us, because they don't have enough information of the sites. So, we're in current conversations with them to see what else we're doing. We're also being asked for a couple of other projects in Belgium and France, and Canary Islands as well, and off the coast of Portugal as well, because once again, they couldn't find someone to actually do the ground investigation to the depths our drill rig can go. So it's still a new scenario for us, so we're still learning a lot of things. But the technology now at least is available for whoever wants to use it.
Good. So just to say that also we have fabrication workshops, and this is one of the items we've built a platform that's currently
in Morlaix
in Wales, and it's got a range of technologies on board for site investigation, for mammal watching, both.
So basically they're just setting up the site, so they want to know basically, what is the impact what will be the impact of mammals on the site, what is the actual tide direction, tide speed, the wave frequency, and the marine traffic as well. So it's basically kind of a survey buoy of sorts at the moment.
That's her. So a quick resume on just on other stuff that we're up to. That's I suppose related to renewables as well, and comes from other parts of the globe. But we're doing a range of multi-inter-isle cable works, which you've probably seen improving around the Orkney Islands. We do, I don't know if anybody actually knows, but Faroese Telecoms, all their telecom cables actually come through Orkney. So they come through UK, Orkney, and then go up to the Faroes. So we actually manage all their cable management. And different types of cable stabilization, depending on what's been affected, whether it's a fisherman's maybe going awry, pulling his anchors a bit too actively, or the scour protection, because there's been what we don't want is free spanning of cables, pipes, or anything. So, big gaps underneath will have an impact. So what we do is do regular jobs for companies like Faroese. So BT, so anybody that's on BT and got BT, again, we support all their underwater cabling by different means. Rock bagging's one of the regular ones that we're doing, just to hold them where they are. And then there's companies that you think, oh, do we mention companies like Shell? Yes, well we do, because it's energy transition. They're coming into the renewable sector, investing in the renewable sector, and they're coming to companies like ourselves to help them develop their technologies as they transition from oil and gas into the renewable sector. And we welcome that. Just to give you an idea, some of the size and scale of, another one of our multicats, but if you actually see the size of the person there versus some of the pipelines we're actually managing, sometimes when you just say you're doing floating pipe management, nobody kind of really understands the scale of it. But if you actually see the people standing next to it, you understand the size of the work that we're doing. This is London Gateway, which has been a huge, it'll be a multi-generational project over the years, but we're also developing and working with companies who are trying to ensure that we get things like free of plastics and free of nylon and other items out of the sea while we're putting in things like mattresses, concrete mattresses. What we're trying to do is make sure that we don't leave a bad footprint in there as well. So we're looking at plastic-free marine mats. We're looking at mats that will also encourage wildlife. So Some of the mats will have different types of grip on them, so that different types of mammal life.
They're basically texturized, so to encourage marine life to develop in there. So they're not like an alien object, or well, they will be, but they will be welcome by all the little creatures of the sea.
Yeah. We're working in Germany to the UK at the moment. We're just about to start more works there. And this is a really interesting project. We're helping a company develop a seaweed farm in Alaska. They've already got one in Namibia. And again, seaweed production is on the up and up globally, and we need the spaces to develop the growth. And these kelps are, how long are they? They're
really big. I don't remember the size, but basically I think the rate they grow like probably 30 centimeters after the first year, almost per day. It's a really good business, I suppose, to get into.
Yeah. So you're in and they're actually harvesting like a farmer would harvest, but they're just nipping off the top and coming in regularly doing that. So if you think of 30 centimeters a day, these are 12, 15 meters, 20 meters.
They're basically in a water depth of like 30 meters, and they just drop in the first 3 meters, 2 meters of it, and then continue harvesting.
For those that have seen the other works, has anybody seen that appear in the Scapa Flow recent? So again, to come in, we've done work like ROV, PUXO, bathy survey, cone penetration. Well, the PUXO was exciting because we actually, right where they wanted to put the platform, there was a torpedo. So we had to deal with that first. So that was a slight delay of our coming in. But I think from deck to water's 66 meters.
Yeah,
am I right?
70 meters, but
yeah. So you don't see the scope of it when you're on land looking across, but it's some size. And just going to finish on the last slide is that we're very pleased that a Mr. Neil Commode of EMEC stuck John's name down and Leask Marine's name down, and we have been involved and got more involved in the Marine Energy Council. Marine Energy Council playing a really major role in helping develop the policy and environment with whichever government's in play. And it's really good to know that the Marine Energy Council is actually a quarter of the board members are either from Orkney or companies are working in Orkney form part of that. So it's hugely influential what's happening. And the benefit is that we've just seen on the AR6 round, we've just seen a 50% increase in the granted funded support for tidal and wave sector in the UK. So again, hugely influential, and a lot of it's driven from here at the one end of the country, trying to convince the other end of the country that it's worth investing in. Hopefully that was interesting enough and not too many nodding heads, so thank you very much indeed. Thank you.
John, Elsa, thank you very much indeed for that. Really interesting. I just love these things because you think you know what's going on in your own patch, and you learn stuff when you come out in the evening. So I've learned a lot this evening as well, which is really good. So thank you so much for that. And it is this point that John made right at the start, that there is so much that is going on here, and it's helping show the rest of the world how to get some of these technologies worked up. And this does have recognition. Really pleased it does have recognition. On Tuesday last week, the next tier of the ministers was set within Westminster. So which government we're having, Cabinet were appointed, next tier of ministers, the Secretaries of State, and then down to the next level of ministers. And the Minister for Climate Change was appointed at 11 o'clock in the morning on Tuesday, and by 2 o'clock they'd phoned us up and said they want to come up to Orkney to see what's going on. Now, I don't know how long a list they would have had, But the point is, you can't get through that many calls between 11 o'clock and 2. So I think it was a fairly short list. And so the point is that this sort of work is really what this is about. This is not just about have you got a widget that turns and generates energy. It's the supply chain. It's the means by which you make this stuff work. I was always taught that in a gold rush, it's not the people who dig the gold that make the money. It's the people who sell them the shovels. And that's really what this is about.
Yeah.
Is that we have an absolute gold rush going on, or we're about to kick off, and it's having the companies that are able to do the clever and intelligent things that are reaching out beyond the normal.
Well, as a supply chain company here, our business has 170 suppliers from Orkney, Orkney, supplying us with services. The wave and tidal sector and EMEC and companies like Aquaterra and Green Marine, all ourselves, all these companies, we've got 400 well-paid jobs already in Orkney and ready to grow, so it really is good news. Nobody seems to want to hear good news for some unknown reason.
You use 4 gravity anchors, which just basically huge chunks of rock or chain or whatever. It's
used chain from the oil and gas sector. So again, renewable hat. We'll buy that scrap. Thank you very much. And so we use that so that we're taught in that position and the vessel doesn't move.
And do they work like conventional anchors where most of your grip is the chain lying on the floor, or does it actually rely on the actual mass of the end?
It is for the weight. It's more than anything in weight.
It's the weight at the end.
So in tidal sites it's hard to use conventional anchors because they don't embed much.
Yeah.
And also in test sites there's a lot of cables around, so usually an anchor will be a higher danger to have it in case of a drag, whereas the clump, it will be a smooth, in case of a dragging, it will be a smooth slide of weight, and you will notice it straight away. So actually, if there were to be a little bit of a shift of the moorings, so you can see that the moorings are getting start to be dragged, we actually just turn on the engines on to compensate for that.
Yes, okay.
But basically, anywhere that because it's tidal development, generally if there's a high tide, there's nothing there apart from the rock base.
Yeah, I can imagine.
So the clumps are there to hold the vessel stationary. That's why we don't generally use anchors. Yeah.
Right, and could I ask, if you're going sideways rather than forward or backwards with a drag, has the vessel got a propulsion system that can push it in any direction?
Yeah.
Yeah. Is that? I don't know all the names. I've seen this things called azimuth thrusters, which are basically propellers that you can spin round.
A DP on the system will work in the same. It's the same style, but it's just inbuilt rather than an outside pod. Yeah.
Right. So it's a thruster that's got like a hydro turbine inside, and you squirt the water out. Yeah. Whichever way it needs to go. Right. Mm-hmm. Okay. Thanks. One final question. Why are they called a multicat?
It's just a brand. It's a brand name from one of the manufacturers that's been developed. But there's a multi-worker. We have a multi-worker, multicat, and a Eurocarrier. So but because there are more multi-cats, which is
it's kind of like the Kleenex situation. It's like it's a paper tissue, but people call it Kleenex.
Right,
so
okay.
Something like that.
Well, that's fine. I'll hand on to somebody else now.
It's a Hoover
and if nobody else has
version.
any questions, I'll come back with another half a dozen.
But the point there is that the hull is not actually a catamaran.
It is not.
It's
a rectangle.
Flat bottom, basically. Yeah. Mark, and then and Robert.
Thank you. Hi, you said these multicats go around the world. How do they get there? Presumably you don't steam them from Orkney to Bermuda or something.
That's a very good question. So what we do is they'll generally go two ways. We'll either put them on a semi-sab. So a semi-sab is a very large ship that will come in to somewhere like Rotterdam or somewhere. We'll go under our own steam to Rotterdam. They will sink the ship down. We'll get on and then I'll lift it again. And then that'll take us to, or as we did coming from Canada, and we've done from
Faroes,
USA as well, we'll come as freight. So they'll lift our vessel up and put it on the deck and freight on top with all the other, where the containers are. So that's the benefit of them. The hulls are 24 metres up to 27 metres long. They're under 200 gross ton, but we freight our vessels around the world, or semi-sub them. Yeah.
Robert? All right.
Thanks. I was thinking back to the All Energy Conference in Aberdeen in 2008, when Neil was asked if he was convinced that Orkney was the right location to have chosen for EMEC, and among the answers that he gave, he said yes because of the can-do attitude of the locals, and having kind of not followed the marine renewable development as closely as I used to when I was working in the local papers. I'm just astounded by the number of stories that have come out in the presentation tonight. And the question I was going to ask was, all these innovations that you've done to fill gaps, without giving any secrets away, are you working on any further ones to cut costs? Or have you cracked them all?
Elsa's the brains of the outfit. I'll let her answer that one.
We're still developing things. As I say, it's not like we have a plan of like, oh, we're going to develop it. I say like a lot of these things we literally just stumble upon them when, we see a project coming and it's like, okay. And to be fair, I would say it's a really fast development process. I say probably the drill rig has took us 5 years, but actually the first 3 years of the whole invention, if you want to call it, they were actually quite fast. The recovery cons probably was something that came up within a month, and now it's like something that we use constantly. We have developers that actually ask us now, they ask for permission to use them. We have 3 or 4 developers who adopt them, which we know we have give them the right to use. I'm quite sure we haven't captured them all, and I'm quite sure we could continue to do that.
The traditional way of engineering is a design engineer will design something, then it'll go to manufacturing engineering, then the drawings will be done, then it'll go to the workshop and it'll get made. The Leask Marine way is, let's go out to the workshop, we'll make it, and then we give it to the design engineers and say, can you draw that we've made and we're using it next week? Isn't that right, Elsa?
Yeah, that's a lot of the things. So, it's it's a quite interesting way of we develop things. I said, our big advantage is we have people like Doogie and Ollie. I don't know if you know them, but basically they're the heads of operations. And I'm an engineer, and I will break the science behind it. But sometimes I will show something, and then I will show it to them, and they were like, that will not work from our boat. I was like, okay. And I'm like, okay. So we need to make this one maybe smaller, things like that. So, it's a constant communication between operations and engineering. And I was like, okay. So I grab my little sketch, go back to my desk, read through something. I was like, what about this? I'm like, yeah, cool. And okay, let's try it. Its advantages, we have the fabrication, the workshop just next door. So as soon as we can and we have material to do it, we do it. One thing, as John pointed out, we try to recycle a lot of things because, there's a lot of steel structures that were used probably for the industry that they should not be just put out to waste or, just completely useless. No, there are actually a lot of things that you can reuse. So I think that's one thing we pride ourselves of. We try to extract as much life of things as we can. Yes, we shop them, we reshape them, we paint them different color, but we try to take the most life as we can, and I think that's something that needs to be encouraged more with the industry moving forward, because a lot of developers would like to come and say oh, we want to build this one, and they want to build them from start, and we got the concept, or we know where the function of the things they want to do, we get it, and we will look around and see what, this one was used for a developer 10 years ago. The steel is still good, the weight's still good. Maybe we need to reinforce things here and there, but why we don't use this one again? Yeah. So I think that's something that we really pride ourselves on.
2 projects we're doing this week is one is we had a company here who had very large steel buoys to keep their device mid-water. And we had a very small developer that wants to put in down in just off France. And he came and said, this is it, this is what my device is like, this is what I need to do. We know what we can do. We'll weld these old buoys together, we'll put a platform between them, job done for you, and just like that. And then the one today was a large offshore wind farm. Went out to the market to say, we've got a problem. We need to dump just a small amount of hard rock next to. We've got scour coming around the bottom of our pylon. We need, but the problem is we don't need a 20,000 ton ship to dump it. How can we work that out? What did we do? We sat this afternoon and went, right, so let's work this out. All right, okay, we'll take a 20-foot open top half height container. We can fill that. We'll make a bed, a frame bed for it with rams, so it looks like what you would a dumper track. And then we'll make a chute, and with a direction and cameras, and we'll just tip. And the offshore wind farm were just astounded that that we were stupid enough to come up with the idea in 5 minutes on the call. B, we'd drawn it. Yeah. Elsa had it back within less than 20 minutes. We had it back to them on paper in a drawing, going, we think this will work. And they just went, that's our problem. So why can we think of that? So again, that's the innovation part of being allowed the freedom of such businesses to just go, well, we've got nothing to lose, let's just have a go at that.
I'll just come in on that, because one of the pieces that is quite interesting about, say, the drilling side of things, there was quite a job to get the permits to actually do the drilling. Yeah. And frankly, the permitting took longer than the design and so much else. And frankly, we need to help all the parts of the system get up to the speed that these guys are working at. So if we're going to tackle climate change, we've got to hit this really hard and throw everything we can at it. And so making sure that everybody's up to speed with this and pointing out that you can move faster than a regulator, we have to help them get to speed as well. Dave had a hand, and then Susan.
So the engineering you're describing is really exciting, but sounds quite terrifying, from much worse than what I'm used to. You're dealing with risks that are 1,000 times bigger than your company. So how do you manage that? Who writes the specifications? How do you develop the contracts to get you going on these jobs?
Well, again, it comes at a price. You don't want to know what my insurance is. But we cover ourselves as a small business here. We cover ourselves for $500 million because that's the damage we could do to somebody's infrastructure if we got it wrong. And the insurance that we pay, our insurance for just managing cables, for when we've never had an incident in our company's life, by the way, on cables, our insurance went up by £38,000 just our cable insurance this year. So it's eye-watering amounts of money of cover. But coming on the other side is the experience and the knowledge. We're reasonably lucky. Lots of people don't know or hear about Leask Marine. And the reason for that is we're a go-to business that generally business to businesses go. You've got a problem, these are the people you need to go and speak to. If you're working high tidal flow area, if you need to lay cable across the Bristol Channel, these are the boys you need to go and speak to, and girls.
Yeah,
again, the knowledge has come, and very quickly in a conversation, they can understand and have the confidence, done it before. But the drill rig has taken a lot of years.
Yeah, and I would say it's not, I know we say like we do a turnaround really fast, but we don't let anything go out until we have all the checks. We do structural checks, and we actually make sure that everything is fit for purpose. Yeah. Before it goes out, we actually stop. We have stopped projects when we know it's a mad rush, a lot of things in operations because weather and things like that. but we don't let things go out unless we are 100% sure.
Yeah.
And that has to do a lot with John said, we're not, in the bigger scheme of things, we're not a big company. Maybe a lot of these multinational companies, you will never know. Like I say, I can put the example of myself. I'm as an engineer, probably will be in an office and I will never meet people of the crew. I will never meet any of the captains of the boats. I will never meet anyone from the workshop. I will just pass my drawing to the next one. This is not happening here, We work with the people, like the people on the boats are friends. Well, now I would say, been almost 8 years at least, they're good friends of mine. I know if I make a mistake, I know what is at risk. So I think that's a big advantage of having like a small family business. We are a big team that is quite like united. So we don't really let things just fast. We know the risk there is, and we take it high.
Yeah. We built a standard. We built the DMV standards or British standards. We've got all. We pride ourselves in all the ISO standards and industry standards that we keep. So we work hard at that, and it comes at a price as well. But that's part of the confidence, and it's a trust of clients seeking a solution at the same time. They know if they can find a cost-effective solution, and they have the confidence. Obviously, we're giving it to them at the early days a lot cheaper than it would than a market price. But again, we're developing with them.
Okay, so can we go on 9? Just go on 9. Susan, and if there's any other questions, we'll take one more maybe.
Thank you. I was just rather tickled when you were speaking there about the seaweed farming. I was just reminded of that. Do you remember a few years ago we had that event with the person who was harvesting seaweed to feed to cattle to stop the...
Yeah.
I thought, my goodness, there's another opportunity there for you all.
Yes, MAS Crayab from Florida State University.
That's right, yeah. I think there is a seaweed farm on the east coast in Britain somewhere as well, and they're doing quite a line. And apparently it's healthier than salt. They grind it up and it's a new food product as well. So I'm just quite intrigued about the spin-offs that come from starting a project. It's just amazing how the brains can just sort these things out.
This Cal company, I think, was trying to develop some kind of plastic alternative as well. So they have a lot of uses. Yeah, it's crazy, really.
Yeah, so they're looking to develop when you have a ready meal, that plastic that nobody can ever get off the top. So they're looking to have that made of seaweed. So again, totally disposable. Yeah.
Last gentleman here.
I was interested in your drilling rig that you made, and you say that when you drilled, you left the head in place. Now, is it telescopic? Is it? How do you break it from your tool? How do you break the head from your tool?
Basically, obviously, there's limitations to what we can do with the length we can do. So, as I said, when we design it for basically uses for small boats. So the maximum length we can install is 7 meters, and that's the capacity. So it's kind of like our target market. We're not lying and saying we can achieve any load. No, we say that we have anchors that can go up to, let's say, 1 meter diameter, 7 meters long, and this is a maximum capacity.
Right.
So we have clients that have higher requirements, so we're working with them to work multiple anchor solutions, so basically kind of a template where you can install 3 anchors in one single area to have a bigger capacity. But the way we disengage is basically we work with shear pins, so basically we reach depth.
You sort of blow it away, blast it away from the masthead. You blow it away from the masthead. Then do you anchor your pins, your cables to the said item you sunk?
Yeah, so it depends a lot of the application. So a lot of our clients pre-install things. So that's basically what we sell is an open top anchor. And then we go to their client and be like, we can give you this anchor, and then we work in conjunction with them to see what is the top is going to be. It might be just a pad on the top with a shackle. It might be an open-ended with a bolting solution on the top with a flange that is probably boltable to a flange that we install on the top of the anchor itself. So it's actually quite an open book basically for everyone to just
Right, I take it it's up to the diver to separate the head, or do you do it
No,
from
it's
the ship?
it's called cheer pin. So basically,
I know.
yeah. So that's it. With the head has a set of rams, and we expect the pins to break, let's say, at 10 tons. So the rams are 15 tons. So when we reach depth, we finish drilling, we activate the rams, and the shear pins break,
Right.
and that's completely
Okay. Thank you.
liberates it.
But we also do what's called like a raptor anchor and a stratolock anchor. So they're anchors that actually can be reversed and taken out completely at the end. So if it's a short-term use for a number of years, we can actually...
like a big roll plug.
Yes,
Yeah.
basically a big robot. So we can take it out again, so there's nothing left on seabed.
Okay. Well,
Thank you.
that has been a really informative evening. So thank you so much for all that information. I really, really appreciate it. As you were saying, you know, there's so many things going on here that you just don't know about, and we're really grateful to John and Elsa as ORF members to actually come and speak. So if people have got other things that they know about and would like to share with others, so I think everybody's found this really interesting this evening. So if there are others who've got stories to tell, this is a great vehicle and a means to do it. Pleased to say, John will be meeting the Minister next Wednesday, when they're up, along with other members of the supply chain, to try and get them to understand, you know, simply what is going on here. Because it's not just we're sitting here with heather in our hair. I wish. So it's, you know, this is a sophisticated economy doing clever stuff and pushing technologies right to the edge and beyond, and making new edges. So I'd like to say, you know, thank you very much indeed, and we show our thanks in the usual way. So thanks.
Thank you.